Good evening. Welcome, everyone. Thank you for joining the Productivity Engineering Silicon Valley meetup. I first want to thank Bruce and Terry and Airbnb for hosting. Let's give them a round of applause for hosting tonight. How many people have been to one of our meetups before? All right. So previously, we've held every single meetup in Los Gatos. And our plan going forward is to alternate between Los Gatos and San Francisco or alternate locations around the peninsula. So hopefully we'll find a location that works for everybody. We're really excited to continue holding these meetups. Sangeet and I have been doing some form of productivity engineering and developer productivity for a while. So it's exciting to hear stories from other companies that are doing something very similar. And we feel like it's a very cool space. I don't know if you want to say anything else.
Sure. I think just to echo what Mike said, one of the other goals we have is to put some structure around this whole area as a domain. I mean, if you think about, SRE 10 years ago, it was just coming into being, if you will, as a space. Likewise, I think there's a lot of opportunity here because, as many of us know, we are all working in this space. So with that, I would also like to put in a request for topics. If there are ideas and things that you'd like to hear about, definitely let us know. For instance, one of the things I'm thinking about is how do we measure all of this, right? So we know we're wasting time, we want to reduce friction. It's all of it sounds like a great thing, but how do you know how much to invest and what's the ROI in it? What metrics are people using, for instance? So if there are other topics like that, would love to hear from you. And otherwise, enjoy and thank you to the speakers.
So we have two talks tonight. First one's going to be from Airbnb on portable CI. Is that right? And then the second one's going to be from Nadav from Netflix about a tool we've been working on, or he's been working on, called Newt, and some of the interesting problems it solves. So, Airbnb.
Cool. All right. Hello, everyone. My name is John Lago. I'm a product manager here at Airbnb. Before I hand it over to Stephan and Juliusz, I just want to talk a little bit about some of the interesting challenges and changes we faced here at Airbnb as we think about developer productivity. So to give some context of our growth and scale, every night, our guests rely on us every night. We have over 2 million guests that rely on Airbnb for their travel plans. We have over 4 million listings in 190 countries. So both guests and hosts all rely on Airbnb. And thus, we here at Airbnb, we depend on developers to make sure that their experience is great. So we have hundreds of developers, and we're still rapidly growing, which provides a lot of interesting kind of scale challenges to us as we rapidly accelerate the number of developers, number of platforms, number of workflows we have to support. And we have a kind of interesting culture, which leads to some interesting challenges that we can talk about a little bit. First of all, here at Airbnb, we encourage developers to own their own impact. So they're encouraged to really not just think about like the specifics of the problem that they're working on, but kind of own and shepherd their changes all the way through from the beginning of development to the end of production and to when it reaches the customers. So they're responsible for that entire experience. And also we have a really fast and iterative process here of continuous deploy, where developers are constantly making changes, constantly pushing them into production at rapid scale, which poses some challenges for us and some interesting things to do with our developer productivity. As our developers' needs have changed, we've had to adapt a lot as well. As I said early on in Airbnb's development, when we were only a few developers, we had this mindset of developers own their own infrastructure. They're responsible for thinking about the infrastructure on which their services run and on which they build and how they deploy. As we moved to 100 developers and up to 1,000 developers, our architecture has gotten more complicated, becoming more service-oriented, something we're also rapidly moving towards faster and faster. And we've also moved from having developers own their infra to having more of that be managed by specific teams, such as developer productivity. So our team, which you're about to hear a little bit about some of the projects we're working on, our mission is really, we want to leverage technology to empower developers to write and ship high-quality work at scale. What this means is we don't want to just like kind of do this for them. We want to make sure that they still have the ownership and they own the impact that they have. We want to provide tools that make that easy for them, that reduce the friction, and that give them the leverage to be more and more productive as our work streams grow more complicated. And as we continue to scale, as our architecture gets more and more complicated, we have to adapt more and more to meet those challenges. So we've already mentioned the talks, but we're going to start with the simple and portable CI using Docker. So Stephan and Juliusz will now talk to you a little bit about our CI challenges. Here you go.
Thanks, John. Hello, how are you? Good. I'm here with Juliusz.
Hello.
We are on the test infrastructure team, which is part of the developer platform team, and we're going to talk about how we basically escaped vendor lock-in with CI providers using Docker. So this is not the whole team, obviously. So Laurent, Juliusz is behind me. Julia, myself, and Mark built everything that you're about to hear about. So I'm super lucky to work with these people. But before we get super deep, I really have to tell you some background, because otherwise it's not going to make sense. So starting in November 2015, which is like a long time ago, since then we've been using two different CI systems. So we've been using Travis. Everybody knows Travis? Pretty much. Okay. So Travis is like the most popular CI system for open source projects, and they also have an enterprise offering. That's what we use. But it turns out that Travis didn't work for some of our biggest repos. I'll talk more about that later. So we have this in-house tool that's called Deployboard, which is also a CI system. Now I should explain a little bit. So let me talk about how we use Travis. So we like Travis. Travis was a good option for us for the past 2 years because it's super easy to set up. As you know, all you need is a file in your repo called .travis.yaml, and it just lists a bunch of steps, and that's your CI job. So we like that about Travis. And it's super familiar. I think like most of you, if not all of you, raised your hands just now. So yeah, everybody knows how Travis works. So I mentioned that some of our biggest repos, we just couldn't get it to work on Travis. So one of our biggest repos is a big Ruby on Rails application that we affectionately call Monorail, like Twitter. And right now it has 100,000 tests, which is awesome, but also difficult because you can imagine we definitely need to parallelize those tests. Travis has parallelism, but we couldn't. It's like not at the scale that we needed. So that didn't work for us. There are a few situations where Travis just didn't provide a timely release cycle for new operating system and software packages updates. So like we wanted to upgrade to Trusty, that's Ubuntu 14.04, and they were a bit slow in getting that to us. And we kind of just didn't understand how Travis worked. So, I mean, all systems break sometimes. And when that happens, we just didn't really know how to debug it super well. So yeah, we built Deployboard. Now, once upon a time, Deployboard was a smallish tool that was only used to deploy code, hence the name. So that was a wonderful time. But I mentioned before that Travis was working well for most of our repos, but not for the biggest ones. So over the course of 2 weeks, we retrofitted Deployboard with CI functionality. And Deployboard works a little bit differently than most CI systems that you probably know, and it's definitely very different from Travis. So I will spend a little bit of time familiarizing you with it. Basically, there's a fixed set of jobs. And they're implemented in the Deployboard code base. And these jobs are meant to be kind of general purpose jobs. So one example of a job is npm test job. So that's a job that is supposed to work on any repo that's like a JavaScript app. It'll run the JavaScript tests. So that was an interesting idea. I have to put general purpose in quotes because the reality is we ended up with a lot of ad hoc jobs that only work on a single repo. It's kind of like, in retrospect, oh yeah, of course we ended up there, but it's not obvious from the beginning. And the way we configure that certain job types should run on certain repos is in another repo that's called Deployboard apps. And this repo basically just has a bunch of JSON files. So that's where the configuration lives. Cool. Okay, so this graph shows proportionally how many commits per half year we've received in the last 2 years. As you can see, we started in the beginning, at the end of 2015, we didn't have that many, and now we have a lot. So we're really pushing the limits of what both of these CI systems can do. So let me talk about some of the limitations of deployboard. So deployboard implements sort of a many-to-many relationship between repos and job types. So I mentioned before, there's like a fixed set of job types. They're shown here on the right, and on the left we have the repos. And these arrows between them indicate that like that job runs on that repo. And you can have many repos for a single job, and you can have many jobs run on a single repo. And that configuration lives in deployboard apps. Contrast that with Travis, which is much simpler. So with Travis, you just have repos, and all the configuration just lives in the repo, in the travis.yaml file. So that's nice. And going back to deployboard, on the operational side, we have each of these boxes are worker queues. And each worker queue corresponds to a particular combination of system dependencies, like Ubuntu 14.04, Ruby 2.1, Node 8, NPM 5. So that's like one combination. Now you can imagine at Airbnb with lots of different apps, lots of different repos. So basically every possible combination, we had to support that. Now in Travis, there's just one queue. It's like all jobs are created equal in Travis land. So the idea with Travis is Travis actually runs your job in a container. And when the job is done, the container is torn down. There's no state left behind. And as a functional programmer, I can tell you this is very appealing to me. So that inspired us. We'll talk more about our inspiration later. Here's the situation. Imagine that you are an engineer on a product team at Airbnb. And you're building a new service and you want to add CI to it. You should have tests on your repo, of course. So how do you do that with deployboard? I'll walk you through what an engineer has to do. It's kind of crazy. So first they have to get the deployboard repo. It's not a repo they normally work in, because it's like it's owned by us, our team, not them. And they have to learn how it works. I mentioned that deployboard is like a big monolithic kind of monorail, so it's non-trivial to do that. Then they have to make the change, write tests, push the branch, kick off a test job. Wow, look at all that. And then finally, like a couple days later, they emerge. They're finally done, but they look like this. So that's not ideal. It's a very high-touch process because and that's if they know to do all that stuff. And the documentation, it could use more. There could always be more. And the reality is they probably have to come to us for help. We'd have to help them. Both parties are kind of slowed down by this whole thing, so not super ideal.
All right, so as you can see, we have some challenges here, and we painted ourselves into a corner, and it's kind of not the situation we want to be in. So after all those experiences, we have a pretty good clarity of what we actually want. So let me go briefly over that. So we want our CI system to be flexible. We want it to allow any possible scenario with any dependencies, any Ubuntu version you want, Ruby version you want, anything you want. It should be easy to set this up. We want it to be easy to maintain. So for the parts that we own, we should understand them fully and be able to debug them if something goes wrong. If we're using a third-party vendor, then we definitely want like a strong SLA commitment that if something goes wrong there, then they're gonna help us quickly. We want CI for people to be easy to set up. As you just saw, like this was not easy to set up, and frequently people reach out to us, and then we just need to spend time together to just set up things that should be simple. We want it to be easy to scale. So no matter how many projects we have in future, how many jobs they have, how sophisticated their CI is, the way we scale it, it should be just adding more workers, and that's about it. And finally, we want it to be portable. So we have high hopes that what we are what we built now and what we're migrating to right now is going to serve us for a long time. But in the past, we switched CI systems several times. So, you know, history likes to repeat itself. So if this happens again, we want this migration to be easy. So we sort of want to abstract away the parts, for example, vendors, parts that we don't have much control over. So this whole effort actually started as an intern project. It was a proof of concept, and it worked out well, and that's why we dedicated more resources to it. So let's go back a little bit to what we have right now, which is not what we want. What we have right now, we have CI jobs that run with the same dependencies as they run on production machines, which should be always a requirement for your CI, because otherwise you have no guarantees that what you're testing is actually what's going to be happening in production. But then, you know, with deploy board that was just described to you, even if a single project uses some old Ruby version like Ruby 193, for whatever reasons, we need a deploy board worker that runs Ruby 193. Now, if the worker runs Ruby 193, that means that deploy board needs to be compatible with Ruby 193 because it's written in Ruby. And we don't use containers there. So it's just one interpreter. So basically, deploy board has to be compatible with all the versions of Ruby we use at Airbnb, which is pretty horrible because we can't even update Rails because it's not like newer versions are not compatible with old Ruby versions. If that wasn't enough, deploy board also depends on Node.js. So just multiply it together and you get the idea of how many variants of deploy board we have. It's pretty terrible. So finally, deploy board builds deploy board. So you could like ask yourself, okay, how do you even start a new worker with new versions of those dependencies if you don't have that worker to build deploy board in the first place? So it's horrible. You just start an instance and like mash commands through SSH until it works, and then you end up with some sort of built artifact that you can deploy, and you're like, oh, okay, now we can start some workers. So that's how we feel on the deploy board side. So, you know, we wanted to get away from this, to get away from those jobs written in Ruby as a part of deploy board's code base. So we asked ourselves a question. So what is actually a job? What should it be? So yeah, it used to be a class in Ruby, but we wanted to decouple it from deploy board. So we wanted a new format that would have nothing to do with it. So essentially what CI jobs are, they're just a sequence of commands where you collect either standard output or artifacts or both. And that's pretty much it. So what we decided to do, at first we thought like, we're going to make deploy board just read this new simple format. But then we thought, you know what, we're going to build a CLI, and we're going to use it not only in deploy board, but we can use it anywhere. So people can actually run their CI jobs in the dev environment. They don't even need to push it and like run it in CI. They can test it locally. It's, you know, it can run anywhere where you have a Docker daemon. So we called this Jorb because it's job, and the Ruby extension is RB. That's about. So let me walk you briefly through like this evolution of the job format that we came up with. At first, you would say, okay, this is just a sequence of commands. So this is actually similar to what you would do in Travis. But that was not enough for our use case, because we have a bunch of old legacy infrastructure that really expects us to put things in certain places and do them in a certain way. And we didn't want to, you know, rewrite everything from scratch at once. So we introduced step types. So the typical step type is run, which just runs a command inside of a container. So this is what you would expect. But then we have some additional types that prepare things for our old legacy infrastructure. And another reason we didn't want to run those things inside of a container, because then we would be back to the same problem where we need some tools inside of that container, and we might have some dependency conflicts, like with deploy board on deploy board workers. So those steps actually run outside of the container. We have a couple of more steps. An example of this is there are steps for caching. So if we want CI to run as fast as possible. And sometimes when you use some package managers, you install some dependencies, like they compile C libraries. It takes a while. So what we do, we just have a save cache step. You point it to a directory. It tars up all the contents. And then the restore cache step just downloads it on the next CI run. That is as long as the cache key didn't change. And cache key here depends on the gemfile.log file, which, if you know Ruby, that's where Ruby projects define their dependencies. So if you change the dependencies, the cache is busted. So there's one more piece of this file format, at least in the first version. All those jobs, they need to say what kind of environment they actually want to run in. So our first stab at this was to just have a set of keys and say like, oh, I want this Ruby version, this Node version, this NPM version. Now this has some problems because the way we built this at first is that we used to have 30 plus queues in deploy board, and when we built this, we generate 30 plus Docker images. We pre-built them. So it's a little bit better because it's easier to build an image than to start those deploy board workers, queues, whatever. But it's still not great. Also, what if you want some other dependencies? That actually didn't work at all. It was just like for a bunch of projects that only used Ruby and Node.js, and that's what we started with. So we had to do better. So what we decided to do, we thought, you know what, why not just let people write their own Docker files and just, everyone just write whatever they want in their Docker file, and that sort of sets up the stage for their CI. So, this is a simple idea, but comes with one caveat, which is that building images is slow. It can take up to several minutes, so we can't really afford to do this on every CI run of every single project. So we still wanted everyone to, the experience to be as pleasant as possible. We didn't want people to build those images, then manually put them in some registry, then change the reference in their CI to point to the new image. So we wanted all of this to happen behind the scenes. So we decided to cache them behind the scenes. And the way this works, this is a simplification, but roughly illustrates the idea. We calculate a checksum of a Docker file, and then we just tag an image with that checksum, and we push it to the registry. The user of the CI, the developer, doesn't even know that's happening. So the next time their CI runs, if we find an image with that checksum, then we just use it. That means that the Docker file hasn't changed. If we don't find an image like that, then we just build it from scratch. And they don't change often because the steps themselves are not in the Docker file, the CI steps, but only the dependencies. So installing Ruby, Java, Node.js, things like that.
So Juliusz just described Jorb, which is our CI tool for running jobs in a container. And we're super proud of that. But it's not a complete CI solution by itself, because you need something that can basically dispatch those jobs every time someone pushes a commit, and you need some UI for displaying that output. So we decided to settle on Buildkite. So Buildkite, the way it works is their UI is hosted on buildkite.com. And so when an engineer wants to see the output of one of their jobs, they just go to buildkite.com and it shows up there. But we control the workers. So basically all we have to do is install the Buildkite agent on our workers, and then the Buildkite agent can use Jorb. So this is great because now we can hopefully start to stop maintaining this redundant functionality in deploy board and just use Buildkite, because what they built is actually pretty awesome. It's been working well for us, so just let them do it. And we can use Jorb to run jobs. But Jorb runs everywhere. It doesn't just run in Buildkite. I mean, all it needs is Docker and Ruby. So basically everywhere. This is what Buildkite looks like. It's a lot like Travis, the UI. So this is a job that's running here. You can see the output of running the tests, and it's just like some text, but it actually has like really nice collapsible sections. So you can see each section corresponds to a step in the Jorb job. And there's another job down here, Rubocop. So you can parallelize the jobs. And now, let's say your job failed in Buildkite, and you don't really know why. You want to like debug it. So if you were just using like an ordinary CI solution like Travis, it might be kind of hard to reproduce exactly the results that you see in Travis. But here with Jorb, Jorb runs in the dev environment that every engineer at Airbnb has. So all they have to do is run a simple command, and then their job is like, it just runs locally. And if they need to, they can actually connect to the container afterwards to like debug. They can like inspect files or try to run the test manually. So we like this because it's super reproducible. Okay, so just to like compare and contrast. So this is the Jorb world. You can see it's very similar to the Travis world, which is up here at the top. Every repo has just the configuration that it needs and nothing else for running the CI. And there's no like central place for all the CI configuration. It's just kind of distributed. But the maybe like one main difference is that with Jorb we can actually run multiple jobs in a repo, and with Travis you kind of get one travis.yaml. You have to like cram everything in there. This is what deployboard was, or what it still is. So you remember that picture? Okay. All right. So on the operational side, this is a lot nicer for us because we only have to maintain one queue. There's just one queue. It runs Jorb jobs. All jobs are created equal. It's a lot like how Travis works. Contrast that with deployboard, where we had 35 queues. Okay, so I want to talk about how do we, after we built this awesome, cool CI thing that we're super proud of, how do we get people to migrate all their CI repos, all the CI for their repos to use Jorb? We started with 431 repos. This was at the beginning of February. We had 431 repos that were using Travis. Most of those repos we had never even heard of. That's like a lot of repos. We only work on like 3. So, so obviously we could not migrate all of them by ourselves. So our strategy was to leverage the power of robots and people. So the first thing we did is we sent a bunch of public service announcements to the whole engineering team. We're saying, okay, Travis is going to be deprecated. We're going to pull the plug. So we need your help migrating your repos to Jorb and Buildkite. Then, we wanted to make it super easy. We wanted to kind of automate as much of the work as possible. So we actually created 431 pull requests. So 1 pull request per repo that's using Travis to set up all the configuration that they need to run a Jorb job in Buildkite. So that means basically an empty Dockerfile, a job file that prints hello world, just like a skeleton that they can modify. That actually served 2 purposes. One was to make it easier for them, but also another one was we left those pull requests open, and we wanted the owners of those repos to merge them so that we could use that to determine who owns those repos, because it's actually it's not easy to figure out, at least at Airbnb, who owns what sometimes. So yeah, we wanted to know who owns every repo so that we can guide them through the rest of the migration process. Now, it turns out that when you create a bunch of pull requests, like hundreds of pull requests that look like they're generated by a robot, people will tend to ignore them. That's what we found. So we built another robot. We built another robot to nag people. I'll talk more about that later. And then we wanted to make it super, super easy. So we built a tool that will try to read the .travis.yaml file from their repo and convert it into the equivalent Jorb job. So it'll take the steps from the travis.yaml and the dependencies, and it will install those in the Dockerfile and then run the steps. It's not perfect, but when it works, it means that the work you have to do to port a repo is under an hour in the happy case. We also set up a Slack channel. We use Slack for communication at Airbnb, and we set up a Slack channel to enable people to come to us for help if they have any questions, of which they did many. And then we built a dashboard so we could track metrics and see how people are converting through this flow. All right, so this is an example of one of those pull requests that we created to set up Jorb job, to set up Jorb for Buildkite. You definitely don't have to read all that. It's like basically, this is just the instructions that we send out so that people know how to set up Jorb, how to do all that stuff. And you can see at the bottom, we tagged people in this pull request. And we have a Slack integration. So when people get tagged, they get a notification. It's kind of hard to ignore. We tried to determine who owns the repo based on who like committed to the repo most recently, which is 100% not perfect. But that's why we built the second robot. Okay. Speaking of that robot, so we called it Nagatron. It's a robot for nagging. And it's actually a super simple command line tool. You just run it, and it just generates these comments in the pull request. So it tries to tag people, Frodo and Gandalf. And you can like customize the message. It's an ERB template. You can actually have it. We use this to tag people's managers even. We unleashed Nagatron 3 times within the course of a week, and this is what we saw. So this is like the trough of sorrows, the period where people are like ignoring us. And then this is what happens when we ran Nagatron. It's like, as you can see, it was super effective. So the lesson is automate everything that you can, even when it involves people. This is an example of running the Travis to Jorb converter tool. So basically, it just reads your travis.yaml, and it leaves a bunch of files behind that you are free to then commit to your repo. You'd make a pull request. It doesn't. You might find that like Travis had magically installed some random stuff that you were depending on, but you didn't know it, like MySQL. So in those cases, you'd have to like kind of debug the job a little bit. That's why we set up this Slack channel. But in a lot of cases, it worked just fine, and you didn't have to make any modifications. So that was great. And then we started this three weeks ago, and already we're seeing more than half of the repos are like completely migrated, which means they don't even have a travis.yaml file anymore in the repos. So they're just like not using Travis. So we're super happy with this progress, but we know that like the last bit is going to be the hardest part. So that's still to come.
All right, so the migration finally is going smoothly, but we did stumble upon some challenges. So I'm just going to quickly mention some of them. So the first one was Docker stability. We sort of naively assumed, not being Docker experts, at least at the beginning of this process, that it's been around for a while. If you satisfy the requirements, you have kernel that is recent enough in Linux and whatnot, it will just run. Maybe it will run slower or like not as fast as you would like it to be if you misconfigure something, but it will run. That wasn't exactly the case. So we ambitiously started by running 31 containers per VM, and maybe that was part of a problem, or maybe now we understood better why some people have reasons to run fewer. Like, for example, Travis recommends 4 containers per VM. So 2 big problems that we had with stability during the first week that we didn't encounter before because we just didn't have enough volume were CPU lockups, and as a result, VMs just spontaneously rebooting. This is actually not as bad as it sounds, because when it reboots, then everything is back to normal. So just a few jobs fail, and it doesn't happen too often, but still, we didn't want it to happen. And then another one, which was more problematic because it didn't fix itself, was that Docker daemon would just completely freeze up after about 2 days of use, and then whatever Docker command you try to type, it just doesn't work. It just hangs. Nothing happens. So the first one was actually fixed really easily by just updating the kernel, Linux kernel. And the second one was actually related to Docker storage drivers. So it's a big subject. When you Google for Docker storage drivers, it's a lot of issues and people trying different things. This is one of the quotes that I found. And funnily enough, the first driver that we were running with was the device mapper. We thought like, okay, it was like long-time default for Red Hat and Fedora, and it's been like in there for a long time. We're going to try this. Didn't work that great. So those freeze-ups of the Docker daemon actually stopped when we switched to a UFS, which is, you think, okay, problem is solved. But the problem with a UFS is that the Linux, it was never accepted in the Linux kernel, actually. So it only exists in Debian and Ubuntu, and they just keep patching the kernel when they release a new version. But at some point, maybe it's like, oh, we can't apply that patch anymore, no one wants to work on it, and it just disappears. So what we're going to try to do, we're going to try to switch to overlay 2, which is the new recommended default, but it hasn't been around for that long, so we have to be careful about that. So one more thing that we don't have a great solution for yet is it would be great to have on-demand resources, because we also sort of naively thought that if we're just going to be migrating from Travis for now, if we have those fixed size containers of just, let's say, 1 CPU and 1.5 gig of memory, that should be enough for those projects that we've been running on Travis. As it happens, we're actually not sure how it happens, but we suspect that Travis wasn't very strict about enforcing resources limits. So for example, Jest, that tries to parallelize its JavaScript tests, would run fast on Travis and would run really slowly on our new system. Because when we tried to, just for testing, increase the number of CPUs to what Travis worker had in total, not in one container, then suddenly it's run with the same speed. So we're like, oh, okay. So I guess we have to figure this out. And we lied a little bit about having just one queue. That's a temporary solution. We have 2 queues. We have one queue that has more CPUs per container. We're not happy with that solution. Ideally, we would like something like this, that you just configure in your job, like how many CPUs you need and how much memory. But that brings a lot of problems, like how many containers can you run on one machine now? Like we don't want to write our own scheduler. Like people already did that before. So maybe we'll use Kubernetes. We don't know yet.
So another problem that we encountered is that in Travis, it's really common to write Travis jobs that depend on some kind of database, or like Memcache or Redis or something like that. And Travis actually makes this super easy, because they just Travis will just run those services in the background. And they'll set up like a default user. You can connect to them super easily. This is a problem for us because we are basically just running a empty Ubuntu Docker image. We tried installing MySQL in the Docker image and see what happens. And then we ran into this. Since like MySQL in Docker is tricky, and it doesn't work with overlay 2, which is the storage engine that we want to start using. So you get this error, and it's like, I don't know. We Googled it, and we found a sort of convoluted solution. But we can't expect every engineer to, like at Airbnb, to have to solve this on their own. So our short-term solution is we basically just distribute a set of scripts that will install and run MySQL and other services like that in the background. So basically, the users would just have to put this in their Dockerfile if they want MySQL. So, I mean, it's not great. A longer-term solution is if we should probably use something like Docker Compose, where we could run multiple containers at the same time, and they could talk to each other. But that's further down the road. Right now, we acknowledge that we're using Docker in a sort of non-standard way, because with Docker, you're supposed to run just one process or one service. But we're just running MySQL in the background. So yeah, that's how things are for now.
So let me just talk about a few things that we know already we will have to do, just very briefly. Definitely, there's still a lot of work that we have to do. So one of those things is secrets. That might not be the most common feature you think of when you think about CI systems, but if you want things as uploading things to a custom S3 bucket, or like you want to publish comments to GitHub or something. You need some sort of credentials or tokens that you probably don't want to store in plain text. So we already have an idea how to solve this. We still want the entire CI to be in one place in your repo. So we're just going to use a key pair. We're going to use a public key to encrypt secrets, and then the workers will have a private key, and only workers will be able to read them. But still work in progress. We also, another feature that is not very common to CI systems that we used in the past, but we actually do want it. Maybe it seems like it goes against having all your CI in one repo, but there are a few valid use cases for global jobs, so jobs that would run for every repo. You don't have to configure them. And the majority of those use cases are security use cases. So our security team wants to have a job that just checks, for example, for leaked secrets and things like that. And obviously, they don't want people to opt out of that. So we mentioned this one, Docker Compose, but then how do we limit resources? We don't know that yet. Maybe not Docker Compose, maybe straight to Kubernetes. We don't know. In the ideal case, if we manage to get rid of a lot of our legacy stuff, maybe we can ditch the whole idea of step types and just run everything in the container, which would also simplify things a bit. So that's all. Thank you for coming, and not sure if we have like maybe time for 1-2 questions. If there are a lot of doubts, no, we don't have time for questions. Okay, so those are these are our emails, and we're also going to stay after the second presentation so we can talk there. Thank you.